So for this portion of the lab, I'm demonstrating the colors turning on and off. I'm also demonstrating that I completed the circuit, and I have multiple lights. I'm using the Raspberry Pi to do this, and the code is over here. This is really simple. And please let me know if I need to be recording on my computer, as I can do this too, but it is significantly easier to keep this all on my camera. All I'm doing is I'm just importing the RPI GPO packages, so that way I can utilize the functions built in for the RPI. I'm telling warnings to turn off for now, and I'm setting the mode to BCM because I like using the numbers that are on the board itself as opposed to ones I can't look up as easily. Anyway, all I do is I tell red is pin input 4, blue is pin 27, and green is pin 22. I initialize these, initialize them to low, and then while the function is true, which is always in this case until I hit Control C, I want it to turn green or red on high, then blue, then green, while waiting half a second in between all of these, and then turn low after waiting on a second on all of these. So you get this nice step where it builds up and then turns off, and it looks like a nice pattern. For the resistor values I used, I don't remember the exact values for each one since they're all different, since that was what was given to us, but I do know they're all above the bare minimum of 40 ohms, as the RPI outputs output 3.3 volts. So the lights will use 2.5 of those volts. So the minimum resistance that can be used in this scenario is 40 ohms. I think most of them are around 200. And that concludes it for this portion of the lab. I'll get back to you with the more interesting part of the lab right after this. So in this demonstration, I'm using the pulse width modulation in order to change the intensities of the lights. I just kept the 3 in because I didn't feel like taking any out. I'm still using the Raspberry Pi. My setup did not change at all from the last video. The only thing that's changed is the code, as seen here. Strictly running through it, everything above here is the same as before. The only difference is I am now initializing some pulse width modulation objects through the GPO.pwm function. There we go. I'm initializing it at 100 hertz, so full, really just it's oscillating at 100 hertz, and then I make my duty cycle 0. And then I start at this 0 duty cycle, so it's off. And then I just say while true, so while forever. I tell it to go up to a full duty cycle at increments of 5. And here I'm feeding that to each light. And then I'm sleeping for 0.05 seconds, so it should be done pretty quickly. And then I go, once that's done, then I want it to decrease from 100 hertz to back down to 0. So that's what this for loop is for. So this code is heavily influenced by ones available online. I cannot take total credit for it. I only modified it to meet the needs of what was already set up. For this video, I'll be demonstrating the button to have the lights turn on and off when pressed. Still the same setup as last time. The only difference is I removed an LED to get some wires back. I ran out of male to female wires, but in any case, all I'm doing is detecting the input from this button and setting it 5 volts. And anyway, if I press it, they turn on. If I let go, they turn off. So this is the code. It's fairly simple. The only difference here is I initiate a button to pin 23. I am still using the BCM convention. And the notable factor is the button is an input, but it is also a pull-down resistor, so that way the voltage goes to 0 when there is no signal, which is more often than not. So the actual body of the code is pretty simple. While true, if it is high, then send the LEDs to be high, sleep for a second. If it's false, then turn the LEDs off. And finally, if there's a keyboard interrupt, then it'll end the code, and then finally it cleans up at the end. Now, if you'll notice, this is a 1 second here, and that's why I paused. Oh, this is 1 second in here too. Okay, never mind. Okay, so for this video, I'll be demonstrating the potentiometer and the simple circuit. So there's no code written for this. This is just a circuit. So I'm feeding it 5 volts into the potentiometer. The signal is the middle pin going into the positive end of the diode. The diode's fed to ground. The ground is commoned with the common ground of the potentiometer. The setups are really close and ugly. I did this just to avoid male-to-male wires going everywhere, and these ones are really long, so I didn't want a rat's nest going on. But as you can see, the more I turn it, the more current is being fed through the diode. I'm scared to turn it more past this point. I don't want it to explode. So the farther I turn it, looks like clockwise. Is that right? No, counterclockwise. The brighter it gets, which means the lower the resistance. And if I turn it clockwise, then it will become darker. So I'm increasing the resistance. And yeah, that's the potentiometer.